Oops, I actually muted myself. Oops, hey. Hey, everybody, welcome to another episode of What's Up with the Universe. I'm your host, Eli Hugh, and I want to welcome everybody here who's live in the chat right now and who's everybody watching this on the live stream. I want to thank you for ringing that bell, because if you did not get a chance to ring that bell, that means you are very good remembering what time this show is. Thank you. If you have not rang this bell and not subscribed and just searching for a little science show, thank you. Welcome. Hey, welcome everybody. And on that note, let's say hi to some people who are in the chat right now. Some loyal viewers here. We got Bio Mike in the chat. We got Mountains of Elysium, Captain Trek. And yes, Mountains of Elysium, MON. That's supposed to be Eli Who live stream. And hey, LDG. Well, sorry, Geeks Enjoying Erotica. I forgot you changed your name. Well, today we are going to be talking about moons. Yes, moons. And we are going to be doing a little tour of moons of our solar system. And what better way to start out by talking about moons than our own moon? Yes. The moon, it's a natural satellite of Earth. It's visible by reflection of sunlight and traveling around the Earth in a singularly elliptical orbit at an average distance of about 237,000 miles. Hi, Yvette. How you doing? Yes, Yvette, she is my favorite quantum physicist. Okay, a little bit more about the moon, by the way. It's basically, the moon, it's a cornerstone of planetary science. I mean, without plate tectonics or weather to erase evidence of its past, our closest neighbor in space preserves a record of all the geological history that has shaped our solar system, including our own planet. I mean, evidence suggests that about 4.5 billion years ago, a Mars-sized object basically crashed into the early Earth, and debris from that likely impact formed the moon. Yes, there are such things as moonquakes. Compared to the Earth, it's quite active world. I mean, you got tidal forces, meteoroid impacts, thermal changes in rock near the surface. They all trigger different seismic disturbances. I mean, the coldest place that's measured in the solar system happens to be recorded at our moon. It's not far in the Kuiper Belt. It's in our moon. Some of the polar regions in the some of the southern craters in the polar region, they are darkened by a permanent shadow, basically that harbors water ice. And I'm going to get into that in a little bit. So far to this date, only 12 humans have actually walked on the moon. All of the astronauts from the NASA Apollo mission in the 60s and 70s. Of course, the new Artemis program that NASA has, they're planning to take somebody else to the moon, and I believe it's going to be a woman this time. Some of the generally common questions asked about the moon, basically like, does the moon make its own light? Like the sun. Well, the answer is no. The moon reflects light of the sun, just as planets do. I mean, the bright part of the moon is experienced in daytime, of course. Some people even ask, hey, does the moon rotate? Yes, it does. The moon does rotate. The time it takes for the moon to rotate once around its axis is equal to the time it takes for the moon to orbit once around the Earth. I mean, this keeps the same side of the moon facing towards the Earth throughout the month. If the moon did not rotate on its axis at all, or if it rotated at any other rate, then we would see different sides of the moon throughout the whole entire month. Basically, is there a dark side of the moon? The answer is no. The moon has no side that is constantly dark. Yeah, I know a lot of people don't believe that, but as the moon rotates, different parts of its surface experience day and night. During the full moon, it is daytime on the side of the moon that faces the Earth, also called the near side. During a new moon, it is night on the near side and day on the far side. And hail Kai! Now you know I'm not going to highlight the mountains. Basically, another question is, are the phases of the moon caused by shadows from the Earth? Actually, no, they are not. The moon is always half lit. Remember this. Fun fact, the moon is always half lit. The side of the moon facing the sun appears bright because it reflects sunlight, and the side of the moon facing away from the sun is dark. Our perspective on the half lit moon changes as the moon orbits the Earth. When the side nearest to us is fully lit, we call this a full moon. Not when you put on your pants. That's a different full moon. When the far side is fully lit and the near side is dark, we call this a new moon. When we see other phases, we're looking at the line between lunar night and day, basically the dark part and the bright part. I mean, occasionally the sun, the earth, and moon align so that Earth's shadow makes the face of the full moon appear on the dark and redder than usual. This is called a lunar eclipse. Some people ask, hey, can I see the moon during the day? Yes, you can. Look up sometimes. Because basically, the moon is just as much as during the day as it is at night. But sometimes you may not notice it as easily because the sun is also up. And because of the moon phases that are mostly visible in daylight show us only a little bit of the moon's bright side. Like the crescent moon phases. Of course, the moon is very hard to see during the daytime. People ask, hey, how often does the moon go around the Earth every day? Well, it takes about 1 month for the Earth to orbit the Earth. That's 27.3 days to complete a revolution, but 29.5 days to change from new moon to new moon. And some people also even ask, hey, can people in different countries see different phases of the moon on the same day? Actually, the answer is no, because everyone sees the same phases of the moon. People in the north and south of the equator do see the moon's current phases from different angles. Although if you travel from the other hemisphere, the moon would be in the same phase as it is at home. That would appear upside down compared to what you're used to because of the curvature of the Earth. Some people even wonder what gravity, about the moon's gravity. Does the moon have any gravity? Do things basically float up when it drops on the moon, or does it just sink like down on Earth? Well, the moon does have gravity, because the moon has less mass than Earth, which means it's smaller and the gravitational pull is weaker. On the moon, you'd be able to jump about 6 times as high as you can on Earth, but you will still come back down, so you cannot pull a Superman and fly off the moon. I know, I wish I could do that sometimes. Basically, let's see. In depth about the moon. The moon moderates Earth's wall on its axis, leading to a relatively stable climate over billions of years. From Earth, we have always seen the same side of the face of the moon because the moon is spinning on its axis at the same speed that's going around the Earth, that is, in its synchronous rotation with Earth. The lunar terrain itself, the light areas of the moon are known as the highlands. The dark features called Maria, which is Latin for seas, are impact basins that were filled with lava between 4.2 and about 1.2 billion years ago. These light and dark areas, they represent rocks of different composition and of different ages, which basically provide evidence for how the early crust may have crystallized from a lunar magma ocean. And we're going to get into the crust in a little bit in the interior of the moon. Let's see, the craters. The craters themselves, they have basically been observed for about billions of years because there is no atmosphere to erase them and erode them like there is on Earth. Many theories propose and highlight about how the moon was formed, but the leading theory that's going around the scientific community is that the moon's origin is that of a Mars-sized object. Basically, some people call it Phobos. It collided with Earth approximately 4.5 billion years ago at the formation of our own planet. The resulting debris from both the Earth and the impact planets basically accumulated to form our natural own satellite, our moon. When it was first formed, it was basically in a molten state. Within about 100 million years, most of the global magma ocean, yeah, I like to say that, the magma ocean, have basically crystallized with a less dense rock floating upward and eventually forming the lunar crust. Of course, nobody really knows this yet because we haven't really drilled into the total surface. But the early moon, it may have developed an inner dynamo. It's the mechanism for global magnetic fields for terrestrial planets. In case you didn't know what that was, the science of basically of ancient times of volcanism, the arid, lifeless moon basically has remained nearly unchanged all this time, except when the astronauts came and put litter on it. Yeah, they did litter. I mean, nearly the entire moon's surface is covered in a giant rubble pile. This charcoaly gray powdery dust and rock debris. It's called lunar regolith. That's the top layer of the crust. Beneath the region of the fractured bedrock is referred to as the megalorock. Oops, wrong button. When we decided to explore the moon itself, it was actually not visited by Americans. It was first visited by the Soviet Union's Luna 1 and 2 in 1959. And of course, as of April 2019, 7 nations have followed in pursuit to the moon. The US sent 3 classes of robotic missions to prepare the way for human explorations, which is the Rangers, the Orbiters, which mapped the lunar surface. The Surveyors were also basically soft landers. The very first humans who landed on the moon, in case you were not aware of this, was on July 20th, 1969. Yes, it was during the Apollo missions of 69 to 72. They actually first used a car called the Lunar Rover. It traveled the surface of the moon. Without this lunar rover, they were unable to take about 840 pounds or so of lunar rocks and soil for astronauts to study back home here. Of course, after a long time, lunar exploration resumed in the 90s with the U.S. robotic mission Clementine and the Lunar Prospector. I mean, well, both of these results suggested that water ice might be present in the lunar poles. But, get this, a controlled impact of the Prospector spacecraft produced no observable water. When they crashed the Prospector spacecraft into the surface, they did not find any water then. So, what the U.S. decided to do was they started a whole new series of robots called the LRO, the Lunar Reconnaissance Orbiter, by the way. Told you, I love acronyms better. And the Lunar Crater Observation and the Sensing Satellites, which is the LCROSS, in 2009. Excuse me for a second. In March 2019, the former NASA Administrator Jim Bridenstine announced he sends on planning U.S. astronauts back to the surface of Mars by 2024. So that's only 3 years away. Let's see how soon we can get back to the moon. Of course, the ESA, Japan, China, and India, they've all sent robots to explore the moon. Of course, China has sent 2 rovers, including the first ever one to land on the far side of the moon in 2019. Another first moon exploration was a private company from Israel. They sent a spacecraft to land on the moon in April 2019. The Israel's Bereshit successfully orbited the moon, but was lost during a landing attempt. They tried, but hey, they made it though. Like I was saying before, we are going to be talking about the inside of the moon now, because basically the moon is a different world than Earth, and that means that it's composed of different layers with different compositions. Just like any planetary body, the heaviest materials have sunken down to the core. The lightest material has basically risen up to the outermost layer. Let's take a look at the inside of the moon here. So, let me do this little app here. We are going to be taking a look at the inside of the moon. Yes. Let's actually look at this here. Right now, first quarter. We are at the first quarter of the moon right now. It means one half of the moon appears to be illuminated by direct sunlight. This is basically NASA's. I love NASA page. Okay, some of the features of the moon. We're going to talk about the crust of the moon. If I can actually click on this. Oh, come on. This is supposed to work. Oh, come on. Here we go. Mantle. Okay. try the crust first. Okay, crust will not click on it, but I just described the crust earlier about the regolith. The mantle. No, Mr. CCDV, it's not really made of cheese. Some people think it's blue cheese, but hey. But the mantle itself, it's the core above the mantle and crust. It's made of a denser material such as olivine and pyroxene, which sank down as the moon formed and cooled. The mantle, it's a thickness of roughly 1,350 kilometers for all you people in the UK. And it is far more extensive than the crust, which is the average thickness of 31 miles. Otherwise known as 50 kilometers for otherwise for you in the UK. Like I mentioned earlier, shallow moonquakes. Yes, the moon does experience moonquakes. Okay, here it is. Moonquakes originating or near the surface can be caused by meteorite impacts with the moon. Like I said, it can be caused by impacts of the moon or different metals of the crust when you get a different impact. And there's also, they actually believe there might be some shaking underneath, but that has not been actually confirmed yet. Inside the mantle of the moon, above the core is the mantle and the crust. The mantle is made. Oh, I already read the mantle, didn't I? Yes, I did. Duh. Sorry. Someone should have said something. Nobody's slow typers, aren't you? Let's see. Yvette, sorry, I'm jumping ahead, but what are your thoughts about the liquid water identified? Do you think there's underwater lakes and rivers? Actually, I happen to agree with the scientific studies about that. So I'm going to get into a little bit of the water on the moon in about 6 minutes. I actually believe it, but there's not enough water like lakes and rivers. And nobody cue TLC, please. I'm not going to stick to lakes and rivers that I'm used to. Okay. Whoa, there it is. Sorry, my pacing go up for a second here. The inner core of the moon. At the center of the moon is a dense metallic core. The core is largely comprised of nickel and some iron. It's a solid mass about 300 miles in diameter, or 480 kilometers for your UK folks, or non-Americans. The moon's core is small. Yeah, it's just about 20% of the moon's own diameter. As opposed to other terrestrial worlds like Earth, the core is measured about 50% of the diameters. This is a very, very small core for the moon, because the inner core itself is composed basically of iron and some nickel. Of course, it's a solid mass about 300 miles in kilometer. Or right, the outer inner core. Sorry, that was the inner core. You know, there are no fast typers here to tell me I actually just said this. Wait, am I still frozen? Am I still frozen, or can you hear me? Okay, I just noticed myself. I'm frozen here. But I noticed that the StreamYard is kind of messed up here a little bit. Okay, that's weird. I up to the stream, see what happens. Okay. Anybody typing in? Can you hear me? Because I want to make sure everybody can actually understand what I'm talking about. Otherwise, I'll just continue to act like you guys can hear me. Okay, thank you, Yvette. Yes, we have a fast talker. Good. And I did not know why the camera froze up on me. I think it has to do something with Chrome itself, because it's been messing up so far. Yes, I agree. Samsung's Granite is so reliable. And Doctor Who told me that the moon is actually an egg. I know, Mr. Miles. I saw that episode too. Yeah, it hatched and laid another egg on Doctor Who. But the egg didn't have what the outer core is made of, did it? Did it? Nope. Because solid. The surrounding solid inner core is a fluid outer core. Yes, back to the moon talk. That brings basically the diameter of the core. It's about 410 miles. The moon's core is so small. How small is it? 20% of the moon's diameter. Oh, this thing really is weird. Okay, that's it. I am taking off this thing right here, and let's see what happens. Okay, good. Hey, let's see. Yes, you can see me now. Yay! And I'm not frozen up. Yay! Okay, good. I don't know why that messed up, but we are still going to be talking about moon exploration here. Yes, you can see me. I know. Scary, isn't it? I'm just messing with you. Where was I? Oh, yeah. I was talking about Apollo 11. The Apollo 11 Pacific Seismic Experiment, the PSE. It contained 4 seismometers powered by 2 panels of solar cells, which converted solar energy into electricity, in case you're wondering how solar power works. It also used 3 long-period seismometers and 1 short-period vertical seismometer for measuring meteorite impacts and moonquakes. So far, it's recorded about 100 to 200 hits by meteorites during its whole entire lifetime. The data regarding strength, duration, and approximate direction of the seismic events were relayed back to different tracking stations located on Earth. I already talked about the moon's core. Let's see. Seismometers left on the surface of the moon right now by Apollo astronauts have revealed that the moon does experience moonquakes. So there are moonquakes, like I said before. Deep moonquakes. They found out that the deep moonquakes occur basically around 700 kilometers beneath the lunar surface. They are tidal events, yes, caused by the pull of the Earth's gravity, tugging and stretching the interior structures of the moon. So that means Earth and moon play upon the gravitational forces of each other. Moonquakes, they're originating on or near the surface, can be caused by meteorite impacts with the moon. Another example, basically, of an extremely shallow moonquake can come from a thermal expansion and contraction of rock on or near the surface as it goes from extremely frigid lunar night to very hot lunar daytime, basically when it cools and heats up. The 4th type of moonquake originates mildly shallow depths, about 20 to 30 kilometers, can register up to a startling 5.5 quake. Yeah. And sometimes they can last about 10 minutes. This 4th type of moonquakes, they are still being investigated. Yes, I have, Mr. Miles. I have paid attention to them. Yeah, it has some great pictures. And when the show's over, I'm actually going to put some information about that Chinese rover. Thank you for reminding me about that, Mr. Miles. Some of the moon missions that actually took place were started in the 1950s all the way up until the last 10 years. I mean, the 1950s, it was considered the dawn of the space age. Space age. I have no echo. Should put my echo on here. Let's see. It's the wrong one. There we go. These 3 people featured here are Dr. Wernher von Braun, John Cassini, and Dr. James Van Allen. They are basically inspecting components from the Pioneer 4 spacecraft mission. This picture was taken on March 1st, 1959. I know, Wernher von Braun and Van Allen, some of the greatest scientists I know. In the 1950s, the USA launched a total of 7 missions, and the USSR lost a total of 7 missions as well, which is 14, and none of them were actually successful in landing. Except 1958. This is what happened in Luna 1, the USSR. January 2nd, 1958 was the first to fly by the moon. Luna 2, September 2nd, 1959. It's the first spacecraft to impact the moon. Luna 3, October 4th, 1950 was the very first picture of the far side of the moon. This is the very first picture we ever seen of what any human has ever seen what the other side of the moon looks like. And of course, this picture was taken on October 4th, 1950 by Luna 3, the USSR probe. Yes, they did beat us. It was a space race and they beat us. No American politicians really actually admitted that, but hey, they beat us. In 1960s was formerly known as the Race to the Moon. The U.S. I know, Mountains Elysium. The smiles, it's not a Death Star. That's bad science in a good movie. I don't know why they're flying around space and like, it's headed for that moon. Wait a minute, it's not orbiting anything. Why do they call it a moon? Bad science in a good movie. How many probes did I say USA? Yeah, they had 25 US. They had 25 launches, and USSR did 31 of them. The Roger 7 on July 28, 1964 was the first close-up picture of the moon. This picture right here. This was one of more than 4,300 images that was basically sent back from the flyby. There's a lot of them here. I picked this one because I like this picture here. Luna 9 from the USSR landed on February 3rd, 1966. The close-up image of the Porcelain region of the moon. This was the first survival landing of the moon and snapped the first photos from its surface. This is the very first time we actually saw a surface view from the moon itself. Next off, on December 21st, 1968, Apollo 8 played the very famous Christmas message.
We are now approaching lunar sunrise, and for all the people back, has a message that we would like to send to you. In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good, and divided the light from the darkness. And God called the light day, and the darkness he called night, and the evening and the morning was the first day. And God said, "Let there be a firmament in the midst of the waters, and let it call these seas." And God saw that it was good. And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
Sorry about that. If you guys didn't hear all the sound on that, I apologize. I actually hit the mute button myself. So basically, we're reading passages from the Bible. It's celebrating their successful mission Apollo 8 circling the moon. On July 16, 1969, you may recognize these three individuals from left to center to right. Apollo 11 astronauts: Neil Armstrong, Michael Collins, and Buzz Aldrin. Yes, the very first two men to walk on the moon. Man and Machine. This is an awesome sauce picture. I love this. This is Apollo 12 astronaut Alan Bean. He's standing by the lunar module pilots, and he basically, what's behind him is the Robotic Surveyor 3 spacecraft. Man meets Machine. I love this. This picture was taken by Commander Charles Conrad Jr. It's the LMN Intrepid in the background. I mean, the Intrepid landed on the moon's oceans of storms on 19th of November 1969. and only about 600 feet from the Surveyor 3 spacecraft. The television camera and several other components were taken from the Surveyor 3 and brought back to Earth for scientific study. In 1970s, we decided to sample the moon. Yes, we did. Oh, wrong me. Hey. There was 21 missions in the 1970s, but one of the most notable ones is the Luckenhold. I hope I pronounced that right. The Luckenhold 1. It settled basically on the lunar surface on November 17, 1970. It also carried the very, very first successful robotic lunar rover. It lasted about 10 months, and it was driven by the USSR, Soviet Union. Basically, this is amazing for the technology back then because comparison, it traveled, okay, in 6 years of operation, the Mars Exploratory Rover Opportunity, it traveled about 17 kilometers. After landing, the rover drove down a ramp to the lunar surface and tested 8 wheels. The rover was driven for about 10 kilometers in this whole time. 10 months. Sorry, was it? Is you bet? Okay, sorry. Sorry, I gotta go to sleep. I'll watch what's gonna miss love. Take care, everyone. Okay, you bet. Stand by, everybody. Let's see. The Intrepid, it basically sent back valuable data concerning the composition of the regolith, the soil, close-up views of the local topography, and various important engineering measurements of the regolith itself. And I am not actually sure. Oh, wait. I'm not actually sure if it is a prop from Doctor Who or not. Nah, it's not a prop. So would I, because everybody's got to walk the dinosaur. Yeah, I know, I'm weird. In the 1980s, nothing really happened because there was no lunar missions launched from anywhere on Earth in the 80s. It was all Star Wars, Earth Explorer, Earth Protection until the 1990s. Some people say the 80s rocked, but the 90s rocked when the Cosby robots returned to the moon. Yes. It was nearly a cloudless day over Africa in 1994 when Clementine waved earthward as it crashed to northern lunar pole on its 102nd orbit. This is a picture taken from Clementine. This is Southeast Africa. There's also some notable ones was the Haitian probe from Japan in 1990 and the Lunar Prospector in 1998. In the 2000s became the decade or years of international moon exploration. Finally, everybody else is getting in onto this. Because I have always believed that lunar exploration should not be limited to one country. It should be a planetary exploration. Just like the ISS, you have multiple nations and countries up there. It's not run by one country. It's not run by the ESA. It's not run by NASA. It's run by partnered by everybody. I love that. That's why I loved the last 20 years of this. Because you had Europe getting on this, Japan, China, India. I mean, you had Europe's first probe, basically, ESA Smart 1. It landed successfully in 2004. Also, you also have the Impact LRO upper stages from the Lacrosse mission, like I said, and the Challenger 1. And China's Chang 1 mission. It was the first successful Chinese moon mission in November 5th, 2007. Yeah, November 2007. And of course, 2010, we have China, USA, Israel, India. You have the Chang 2, the Artemis, which was 2011, 2011, I believe. I don't have my notes on that one was actually there, but it's on 11 or 12. And of course, we also have the first non-Soviet rover on the moon, which was China, December 14th, 2013. I have that on my notes. This image right here, this image right here basically shows the gradient rate of different parts of the moon. Where are my notes? Here we are. Where are my notes? Come on, I hit the wrong button again. Here it is. This image right here, it shows the variations in the lunar gravity field It was measured by GRAIL. Sorry, the Gravity Recovery and Interior Laboratory. It's from NASA. It was done during the primary mapping mission in 2012. Right here, these very precise microwave measurements between two spacecraft named Ebb and Flow, they were used to map gravity with high precision and high spatial resolution. I love those names, Ebb and Flow for the spacecraft. Take care, Yvette. Let's see. Oh, yeah. This field, it basically shown resolves blocks on surface about 12 miles, and measurements are 3 to 5 orders of magnitude improved over periods of data. As you can see the different colors on here, the red, it corresponds to mass excess, and blue corresponds to mass deficiencies. The map shows more small-scale detail on the far side of the moon compared to the near side because the far side has many more small craters. And as Yvette talked about earlier, water on the moon. Yes, there has been water discovered on the moon. This is art titled Moon or Shrooms. I'm not sure which one it is. Never mind, I changed it. Well, here, check out this right here about water on the moon, guys.
Since the 1960s, scientists have suspected that frozen water could survive in permanently shadowed craters at the moon's poles. Both hydrogen and oxygen could be trapped within the lunar soil. So to find water on the moon, scientists are looking for indications of hydrogen using the Lunar Reconnaissance Orbiter's LEND neutron detector. By observing the interaction of neutrons with the lunar soil, scientists can interpret how much hydrogen is likely to be present. In order to make a detailed interpretation, however, LEND needs to observe a large number of neutrons. Because LRO is constantly moving, LEND is never over one place long enough to count many neutrons. So, to make a detailed interpretation of neutron flux, scientists add together many measurements from many orbits. With each orbit, LEND's dataset gets larger, and its picture of neutron flux continually improves over time. The dark blue regions in this visualization are places on the south pole of the moon with a suppressed flux of neutrons because of their interaction with hydrogen. These areas strongly suggest the presence of water frozen within the soil. While previous lunar missions have observed indications of hydrogen at the moon's south pole, the LEND measurements for the first time pinpoint where hydrogen, and thus water, is likely to exist. By combining years of LEND data, scientists see accumulating evidence that there is water on the moon. And as LRO continues to return data, our picture of the moon and its water will continue to get better in the years ahead.
Yes, NASA recently announced for the first time that we have confirmed the water molecule, H2O, in sunlit areas of the moon. Yes. I mean, it indicates basically that water has been widely distributed. Oops, wrong button. Hello. It basically has been widely distributed across the whole entire surface of the lunar surface. It's not just in one spot. Some people ask, like, in the late 2000s, people already thought, didn't water exist on the moon? Yeah, like the video said, a number of missions basically surmise that, including the Chandrayaan-1 and NASA Cassini and the Deep Impact Detection of Hydrogen on lunar surfaces, but they cannot actually detect or determine these signs were hydrogen or H2O. Sorry, hydroxyl or H2O. In 2019, data from the LADEE mission, the LADEE, it revealed that OH and or H2O exists on the moon beyond the permanently shadowed regions and expelled throughout micrometer impacts. Oops, wrong button here. There we go. I'm having a fun time with this right now. Yeah, just check this out.
Compared to Earth, the moon appears to be perfectly dry and airless, but in fact, it possesses an extremely sparse atmosphere, barely thicker than a vacuum. From late 2013 to early 2014, a NASA mission called LADEE explored the lunar atmosphere and dust environment. Now, Laddie's observations have led to a new discovery about the moon's water.
During the initial exploration of the moon and the analysis of all the return samples from the Apollo and the lunar missions, we thought the surface of the moon was dry. But more recent missions, like Lunar Prospector, LCROSS, and Lunar Reconnaissance Orbiter, have not only shown that the surface of the moon has a global hydration, but there are actually high concentration of ice water in the permanently shadowed regions of the lunar poles.
In the decades following the Apollo program, a series of robotic explorers revealed tantalizing hints of water on the moon, challenging the conclusion that the moon was dry. The first definitive discovery of water was made in 2008 by the Indian mission Chandrayaan-1, which detected hydroxyl molecules spread across the lunar surface and concentrated at the poles. The following year, NASA's LCROSS mission deliberately impacted part of its launch vehicle into the southern crater Cabeus, ejecting a plume that contained water ice. These discoveries showed that the moon harbors water and that the highest concentrations occur within darkened craters at the poles. But questions remain about the abundance of water at the moon's mid-latitudes. Now, data from Laddie are beginning to provide answers.
What we discovered is that the surface releases its water when the moon is bombarded by micrometeoroids. This is especially noticeable during meteor showers. What we also found is that the surface that's releasing the water is being protected by a layer of few centimeters of dry soil that can only be breached by large micrometeoroids. When the micrometeoroids impact the surface of the moon, most of the material in the crater is vaporized. There is also a shock wave that propagates outward. That shock wave carries enough energy to release the water that's coating the grains of the soil. Most of that water will get released into space, and that's the signature that Laddie detects with its instrument from its orbit.
Laddie observed water being released from within the moon, but the micrometeoroids impacting the moon's surface have a more exotic origin: comets. When Earth passes through the leftover debris trail of a comet, small particles of rock and dust burn up in our atmosphere, creating a meteor shower. On the moon, these micrometeoroids impact the surface, releasing water at the same time that meteor showers are occurring on Earth.
By analyzing the data returned by the neutral mass spectrometer, we found that the intensity and the frequencies of the fluctuations of signals from the water to be perfectly correlated with known meteor streams. For example, we were able to detect a big spike of water during the Geminid meteor shower that occurred in December of 2013.
Knowing how much water is available at the moon's mid-latitudes is important for future exploration. Laddie's observations show that beneath 3 inches of dry lunar soil is a wet layer 10 feet deep, but on the moon, wet is a relative term.
The concentration of water in the wet layer is about 200 to 500 parts per million per weight. So to fill an 8-ounce bottle with lunar water, you would need to squeeze water out of about 1,000 to 2,000 pounds of lunar soil. So while the wet surface is wet, it's drier beneath it.
The search for water on the moon spans 5 decades and is of great interest to future exploration. Thanks to Laddie, we now know that trace amounts of water are widely distributed across the lunar surface, improving our understanding of the moon's geologic past and its continued evolution.
So basically, to sum up what was just said there, this is the very, very first time that we have actually confirmed that the molecules on the similar surface of the moon are H2O. And basically, how much water is on the moon? It's really, really dry. Let me give you a comparison. The Sahara Desert has about 100 times the amount of water than what the Sophia mission detected in the lunar soil. That's how dry the moon is. But there is water. And you're probably wondering, like, why I have a picture here of Earth and 2 moons? Well, does the Earth have more than 1 moon? The definition of the moon basically is a natural satellite that is scattered by a planet's gravitational pull. So when experts say the moon has more than 1 moon, they do not necessarily mean that there are 2 or more of the giant white rocks that we see in the sky. What they actually mean is Earth has pulled into small asteroids that are now caught in its orbit. The term a scientist used on a supercomputer to run simulations on the movement of a 10 billion near-Earth asteroids past our planet. They ran these simulations against the trajectory of 1,800 space rocks that have been pulled into Earth's orbit. Yes, we have more than one. Results showed at least one mini asteroid, usually measuring no more than 3 feet across in diameter, which is virtually nothing compared to the 2,000-mile diameter moon it is, circling our planet at any given time. Let me see. This is actually a cool picture right here because this right here is C62FEDD2. I'm going to tell you about this in a second. And I'll tell you somehow about these little asteroids that get caught in Earth's orbit. The asteroids, they get caught up for about 9 months before they continue the normal orbit around the sun. But some scientists say these asteroids can get stuck there for decades. These mini moons, though, mini moons, no mini me, but mini moon, they don't have a normal orbital path. They twist and turn under different gravitational influences of the moon itself and Earth. One day, scientists do hope to capture one of these mini moons and to basically see what it's actually made of, how it was formed, what the ingredients is. Like I said, this right here, Earth has temporarily captured a new object, possible mini moon called 2020 CD3. On the night of February 15th, Casper Weiser-Kolsch from the Catalina Sky Survey teammate, Teddy Prune, they found a 20th magnitude object. Of course, here it is, 3753 Corinthium, the official name. The near-Earth asteroid object, as you can see in the little circle right here with green, this is where it is. The near-Earth asteroid, it's known to be a companion and a very unusual one. It's basically the choreographed in such a way that it remains stable to avoid collision with our own planet. The relationship was revealed in a paper by Paul Weigert, Kim Einen, and Seppo Mikola. The near-Earth asteroid 3753 that's not all, folks. I can still talk. The NEO 37353. It's basically has an unusual orbit around the Earth, one which is known in the lingo of celestial mechanics as being called co-orbital with the Earth, meaning it shares the Earth's orbit with it. And of course, more practicality as being part of a horseshoe type. This 3753 Kuruth 9, it's basically a Q-type, an Attian asteroid. It's in orbit around the Sun in 1.1 orbital renaissance with the Earth, and it takes exactly 1 year to orbit the Sun. The relative motions of 3753 and the Earth are shown here. After a few orbits, the lines of sight connecting Kuthine to Earth are drawn. Basically, the asteroid appears to orbit the Earth as a result of the frame reference we're using right here. That's the wrong little thing right here. Here it is. As you can see, the center circle is Earth. The white is the moon. The blue is the own little moon, and the yellow is, the blue is the horseshoe. The asteroid, it appears to orbit the Earth. This is the result of the frame reference we're using basically here. The Earth is at the center of the kidney shape. Like I said in the center here. If the Earth and the asteroid are synchronized differently, the asteroid will continue to perform a kidney-shaped loop every year. But of course, the loop would not be centered on the Earth. I mean, for example, if the Earth is only 180 degrees away from the asteroid when it reaches its perihelion, the kidney beam would also be about 180 degrees, i.e., on the other side of the center of our planet. Of course, gravity does not become repulsive. Nope, it is the only interplay between gravity and the physical laws of motion which creates this effect. I mean, okay, consider this. Consider a comet on a high elliptical orbit around the sun. At its closest approach, it doesn't plunge into the sun unless it comes close and actually crash into it. But it just basically rather turns around and heads back away from the sun. So, did the sun's gravity become repulsive? Nope. It's just that the velocity of the comet gained in falling towards the sun enough to be able to be carried away again. The orbits of the comets and other solar system bodies, they are regulated by interplay between gravity and the laws of motion. You cannot break that law of motion. We do not know exactly where Planet X is, but we are speculating there's something out there. In case anybody is unaware, today is January 20th, and I actually want to wish somebody a very happy birthday today. He's not watching, but still, he's an icon to me. Happy birthday, 90th birthday to astronaut Edwin Buzz Aldrin. Yes, Buzzard. Today is his 90th birthday. I want to tell you guys a little quote that he said right here. He said, "Keep in mind that progress is not always linear. It takes constant course correcting and is often a lot of zigzagging. Unfortunately, things happen, accidents occur, and setbacks are usually painful. But that does not mean we quit." This is from his book, No Dream is Too High, Life Lessons for Men Who Walked on the Moon. And I want to thank everybody for taking the time here to watch Exploration of the Moons as we start off our own home, Moon. Next week, we're going to be discussing the many moons of Saturn. Yes, we're going to be talking about moons of Saturn. So stay tuned next week. And to end this show, I'm going to give one more quote by Buzz Aldrin. He said, "Neil Armstrong was the first man to walk on the moon. I'm the first man to piss his pants on the moon." Thank you, everybody, for joining. You all have a good night.